Firstly, who am I? I'm Viktor. I'm a student at BME, and yet I'm working as a trainee in the Graphisoft. I started to learn Vulkan about a half year ago, and I just want to share you my experience with it and a little library I made to help you understand Vulkan. At first time, what I will talk about is what is Vulkan in a general way. Then I will present my little library. I named it Lava Island Engine because it's from Vulkan and you can shorten it as a lie. So then I will talk about how to draw our first triangle with my little wrapper library and how it looked like in Vulkan. And I will present that how this library can help you understand the Vulkan's dependencies and how it works. Then I will talk about how you can configure that, how you can configure the Vulkan through my wrapper library, and I will talk a little bit about how I made the error handling in this library. So, if you know the Vulkan is a graphics library. It's developed by the Kronos group. It's like the OpenGL, but with entirely different structure and entirely different point of view. And why I choose Vulkan is because it's object-oriented. It gives you all the configuration you can do on the driver, and you have to do all that configuration to draw something or just do something in Vulkan, and it's cross-platform. And the cons of the Vulkan that's it's very hard to learn, it's hard to understand how the things work, and after that you understood how the things work, then you have to experiment with it to optimize for your use cases. And because of the configurations, it needs a very long initialization code. So what was my motivation to write this little library? It's under development, and when I started to learn the Vulkan, there was some tutorials I started with, but it will very hard to understand through them, and I wanted to do a readable code with more abstraction levels where you can see through how the Vulkans work. And I wanted a usable interface to draw my things out in a window. And that's why I made this little library. And so on, just to represent how much it takes to draw our first triangle in Vulkan, to set up everything is around 900 lines of code. And what I wanted to do with a good defined interface is to draw a triangle in less than 50 rows. So, and that's how it looks like with my library. You have to create the geometry for it from a vertex data. It means just now the positions and the color of the triangles. Then you have to create the indices for that, and create the renderer, add the scene to the renderer. There's a pointer somewhere. Yeah, I found it. There are the shaders paths. You need the shaders to create the materials. Then you create the whole scene and add it to the renderer, and then you draw anytime you would like. And there's a triangle. Okay, then how does this library work, the live work? At first, as I mentioned, you need the scene. You put the actors to the scene. As under the actors, I mean everything you want to draw. Every object you want to draw, it holds those actors. Then you add the scene to the renderer. This renderer is a guard object. In the constructor, it sets up the Vulkan with a default initialization. Under the default initialization, I mean it creates a window, and you can draw into that window the whole scene. and it is responsible for the life of the render cores. What are the render cores? The render cores are what are responsible for my library's Vulkan objects, and those Vulkan objects are really creating the actually Vulkan's object, and they hold it, and they are hiding the Vulkan's dependencies. So how you can learn from that library? At first, you need to understand, if you start learn the Vulkan, you need to understand how objects are built upon each other and understand the dependencies between them and the configurations. And with those more abstraction levels I made in my libraries, there is a readable code, and you can see the sequence between creating the objects and how they are destroyed, and you can see the dependencies. And I use the Vulkan's logical abstraction in the naming, so if you are interested about an object, you can search for its name in the Vulkan specification, and you can learn how it works and what it does and in which configuration is good for your use cases. So the next thing I wanted with this lie is to separate the application side from the deeper GPU side development, because from the application side, the programmer, I think, doesn't have to know how the render actually works. From the and on the other side, on the Vulkan side, you will want to optimize everything you need to draw or for your use cases. So on the application side, what I think is we'll need is the geometry. You have to define you will want to define geometries and materials. And for the materials, you will need new shaders that I have to provide you to create new shaders through the user interface of my library. New vertex data. The vertex data means that just like in the previous the triangle, it's the data you have to give to the shaders. It's like a position, color, vertex color, and texture color, and that kind of data. And maybe you want to modify these. And uniform data. You maybe want to create new uniform data. The uniform data is the data which changes frame by frame under the rendering. And how can you create new vertex data? It's just it's not too visible, but you have to create you have to implement two static functions which are describing the metadata of the data that your new vertex data is holding. That's because in the construction, the pipeline needs the details of the vertices and the vertex data. And to create new uniform data, it's look like the same in my library, just like this. And if you forget to implement any of those functions, it gives you a build time error, so you can check it. Okay, on the other side, it's how you would configure the Vulkan's objects through my library. There is a structure from which every class is built up. There are public methods, the create and the destroy. Those are called by the renderer. You don't have to care about them if you want to configure. The create function calls the virtual private field create info functions. Those create infos are have to be set up to create the new create Vulkan objects. So I provide for every different create info file virtual function, and later you can configure everything through them. There are no setters because in Vulkan, if you want to change something, you have to tear down the whole Vulkan till that point you want to change and build up again. And how you can configure everything. First you have to inherit from the class you want to configure and override that field create info function with the setup you wanted to, and then you have to inherit from the renderer or the render core. It depends on which holds your type of the Vulkan object, and override the renderer or the new renderer or the renderer core's create object function. This is a function which creates the parent of the type of your new object, and it works. And yeah, there's a little example of that. It's the instance, and there you can see the create and the destroy functions. And there's the get instance, and there are the virtual private fill up info and fill create info. So these are the two create info files you may need to configure for a new kind of instances. And why I think this structure is good for configuration is because if you create new types, you have to name those types, and from those names, you know its configuration, and you know those configurations in build time. So, and there are less. It generates less boilerplate code and hides the Vulkan's dependencies. So you won't have to copy paste all the create functions, and so you just configure those create infos. Okay, and a little bit about error handling. In debug mode, my library generates a log file which logs the creation and the destroys of every Vulkan object, and when you allocate memory or free memory. And in Vulkan there is no runtime validation except those validation layers. So in debug mode, I define these validation layers, and it gives you messages about everything. Yeah, and what are the further plans for my library is to clearly define that application side interface for the scene, and I want to make more optimizations, like memory optimizations, and experiment which is the best use case for my applications. And yeah, and I understand that I was the last person between you and your coffee, so I was really fast, and I would like to thank you for watching. And if you are interested in that library, you can contact me, and it's under development, and it will be published around end of September on GitHub. If you want the link, you can contact me. And yeah, thank you.
Okay, any questions from the audience?
Can you give any advice to others who would like to get into Vulkan? What was something that you would have been knowing? So it would have been good for you to know before starting a new project.
There is an online tutorial. It's called learnvulkan.com or something like that, and it gives you a tutorial until the first triangle. But I really recommend to read the specification about the objects and about how they are working. Yeah.
You mentioned that you use inheritance, so you have a type system and that would need some virtual functions for sure. And have you measured the overhead that you get from using inheritance in your code than to simple plain Vulkan calls like the C API calls?
I think that's that's a compromise to have a readable
yes.
code, and
Productivity.
in those those live Vulkan classes are holding only the Vulkan objects, and those Vulkan objects are holding only pointers to real Vulkan objects, and that's why I kept the default copy constructors and constructor, because it isn't too much resource to copy a pointer.
Okay, thank you.
Also, as another answer, if your application is very simple and there's no control flow around the classes, then most compilers can devirtualize the virtual functions. So I would not expect to be able to measure anything on the complexity of drawing a triangle. Anyone else? Then I would have one last question. You suggested that it is possible to learn Vulkan by using Lie.
Yeah, because it has more abstraction levels, and if you watch the Kronos group's tutorials, it always says only from the top level, top abstraction level, how the Vulkan works, and you can see that from those point of view, because the renderer creates, in sequence all the Vulkan objects, and if you look into those create functions, you can see how a default example code how those objects are really created.
So
It's like a library,
So what you're saying is that learning through Lie isn't as much different than learning really the basic API, because it doesn't add complexity to how an application would be structured.
Yeah, it's a worker library, so you have to understand the Vulkan if you want to use it. But it gives you a default initialization and an idea which objects you will need to draw something out.
Okay. So let's thank our speaker again.
Yeah, thank you very much.